Okay, lesson 12.2. So we just talked about speed, how to calculate speed as distance over time. Um, and velocity, you watched a video that kind of touched on velocity as well. So today we're going to be talking a little bit more about velocity, just a quick review. And then we're going to be moving into two different aspects of motion, momentum, and acceleration, and how they're determined. So first, velocity. So remember last lesson, you learned about speed, and that basically tells you how fast something is moving. Um, right? Now, velocity is what we call a vector. What that means is it also tells you direction. So velocity essentially is the same thing as speed, but it also tells you the direction. So if you're moving 5 miles per hour, that would be your speed. Your velocity could be 5 miles per hour east. Um, so that's the difference between velocity and speed. In parts of motion that describe a location, we call vector quantities. Another aspect of motion is momentum, and you may have heard this word before or even the idea. But basically, it's related to how much force is needed to change motion. That could be how much force is needed to slow down something, to speed up something, to stop something. But it's based on the velocity and the mass of the object. This is where people get like the idea of like you're rolling something down a hill, and the bigger thing is going to be able to keep rolling for longer or roll faster because the momentum has to do with the velocity and the mass. So this is how we're going to calculate it because there's more math in this lesson too. So momentum is represented by the symbol P because we used M for other things. And the unit is kilograms times meters per second. So if you're writing down the unit ever, they put a dot there to notate the multiplication. You could put a multiplication sign too as well. But kilograms times meters per second, that's the unit altogether. That has nothing to do with the number, that's just the unit, just like inches. Whereas mass is in kilograms, so you can get that from putting it like on a balance scale. And your velocity, we know, is just like your speed, but it gives the direction. So you'll multiply your mass by your velocity and get your momentum. You could also do the other. If I gave you your momentum and your mass, you could solve for V. One-step equation. We've done these. So I'll show you an example. So lots of words here. Start at the top with me. So what is the momentum of a car with a mass of 1,300 kilograms traveling north at a speed of 28 meters per second? So it's asking for the momentum. Whenever you get these word problems in science, I would always start, if you had a paper copy, maybe underline the question what it's asking you for. If you're working on the computer like we're doing now, write down what is the actual question so you know what you're solving. What is the momentum? That was the question. So write down your formula for momentum. P equals mv. What is your m? What is your mass? 1,300 kilometers. What is your velocity? 28 meters per second north. I'm sorry for that typo. That should be m/s, not e. Now, solve the problem. Multiply your 1,300 times 28. You end up with 36,400 kilograms times meters per second. See, so before they use the dot to represent the multiplication, here, there's a multiplication sign. Same thing. And you need to put the direction at the end or else it's not velocity. So now let's say that two objects had the same velocity. So you had two balls rolling down the hill, moving at the same velocity, so they're going in the same direction, same speed. The one with the larger mass has the larger momentum. So for example, if you had a 1,500 kilogram car traveling 30 meters per second east, it has a momentum of 45,000 kilograms, not kilometers, sorry, times meters per second east. Now acceleration. So again, you may have heard this before. Acceleration when you're like speeding up, right? When you're trying to start a car. Acceleration also is when you're slowing down though. Acceleration is the rate at which you're changing your velocity. So that could be increasing your velocity. That could also be slowing down your velocity. So just like with speed, we had those distance versus time graphs. With acceleration, we can have speed versus time or velocity versus time if you have directions. And that will give you acceleration. So remember when we graphed distance versus time, it would give us our speed. Now you do speed versus time, it can give you your acceleration. So a couple different ways to see acceleration. If you're accelerating in the same direction as the velocity, then you increase your speed, right? Velocity is going to the right, acceleration is going to the right, you're gonna go faster. If you're accelerating in the opposite direction of the velocity, then you're going to be slowing down. That is called negative acceleration, all right? Because it's going against the velocity. Okay, so now knowing acceleration is how much you change velocity. We use different velocities to calculate acceleration. So I really hope you're writing down all these equations because they're going to be important to remember. For acceleration, you're going to start with your VF. What that means is your final velocity. So what is the velocity at the very end of the time you're calculating? Your V initial is the start one. So what is the velocity when you started calculating? And then divide all that over time. So let's do one of these. So suppose a car starts at rest and reaches a speed of 80 meters per second as it heads east down the street. The acceleration can be calculated as follows. So your V final, what was the speed that it got up to? It started at rest and it got up to 80 meters per second. So that is your final. Initial is where it started, which was rest, 0 meters per second. And the total time was 20 seconds. So subtract and then divide, you would end up with 4 meters per second squared east. So just like in math, when we have area and we square the unit, with acceleration, we are going to square that unit as well. And make sure that you put the direction, because just like with velocity, acceleration is a vector and it needs its direction. So now I'm slowing down. Imagine you had a skateboarder and it's moving in a straight line with a velocity of 3 meters per second north and comes to a stop in 2 seconds. And the final speed is 0. The initial speed was 3. So this time it slowed down. He came to a stop. I'm assuming it's a he. And stop means 0 meters per second. So, but this is still acceleration because it's a change in velocity. So this is how you would calculate the acceleration for that problem. Your V final, where did you end? They ended with a stop, so that's 0 meters per second. V initial, where did you start? When we started calculating, it was 3 meters per second, and the total time was 20 seconds. The direction was north, because remember vector quantity. So you're going to go ahead and subtract. 0 minus 3 is negative 3. Divide that by 20. You would end up with a negative value. Now, negative values are okay when you're calculating, but when you write it, I want you to write it as a positive, but you know that it's a negative acceleration. And since it's negative, though, you're going to change the direction. So remember our picture where we showed the acceleration going opposite directions as the velocity if it's negative? So instead of putting the negative sign, you switch the direction from north to south. Also, I just noticed another error in the slides here. They put 20 seconds. That should be 2 seconds from our last problem. And that would make the answer correct too, because if it was 20, it would actually be 0.15, now 1.5. And the last thing is changing direction. So because acceleration and velocity are both vector quantities, even if you keep a constant motion or speed, if you change direction, that is still changing the acceleration or changing the velocity. So like if you're moving in this on a carousel, the speed's not changing, the horses aren't going any faster or slower. But since you're changing direction each time, you technically are accelerating. So you can change acceleration by moving faster, moving slower, or changing direction.